To properly set up the SAS system requires the following equipment, as defined by the maintenance manual. The SAS system may require setup for a variety of reasons, usually because of component replacement during troubleshooting operations. Here are the principal activities that occur during the SAS setup. 1. If a new or replacement computer is installed, it must be adjusted. If the aircraft's prior SAS numbers are available, they're used as a guideline to adjust the computer to very near the required settings. SAS numbers are like fingerprints of each aircraft's flight characteristics. These numbers are represented by either ohms or voltages values. Hence, if a component is replaced, the replacement part must be readjusted or reconfigured to match the unique flight characteristic fingerprint of the aircraft involved. 2. The vane may need to be adjusted. This is a relatively simple procedure since the vane is locked into position and the body adjusted until a precise voltage measurement is obtained. 3. The flap position transmitter may need to be adjusted to produce the proper output based on flap position. These 3 items are all that routinely require adjustment. The vane and flap position adjustments are standard for all aircraft. The computer adjustments will also take into account the actual flight characteristics of the individual aircraft, so it is unlikely that 2 computers would ever be set exactly the same. In addition to adjustment of the computer, the tester can also be used to check the proper operation of the computer as well. The maintenance manual covers the complete setup procedure. We will confine our discussion to those actions that are applicable to all models. The first item is to see that the computer is properly adjusted. This is accomplished using the tester and the aircraft's original setup numbers. Follow the step-by-step procedures listed in the manual. These procedures will set the computer to work with the actual numbers relevant to the aircraft involved. These numbers are contained on the SAS data sheet supplied with the aircraft. Notice that column A, titled Set Flap Volts To, contains printed numbers. This is because the output of the flap position transmitter is set the same for every aircraft. Notice that column B, titled Set Vane Volts To, is handwritten and will be different for every aircraft. Setting these numbers accurately is very important. The closer these numbers are set, the adjustments to be made in flight will be minimal. Column C specifies which pot to adjust on the computer. Believe it or not, the most common cause of problems during the computer setup is the mechanic inadvertently adjusting the wrong pot. Unfortunately, there are several adjustments that interact with other adjustments. This means that in some cases, if the wrong pot is accidentally turned, you may have to go back to the beginning of the setup procedure and start again. Column D specifies the proper voltages that must be obtained. Whether you're using a tester that incorporates a voltmeter or a separate standalone unit, you must be able to measure and adjust these voltages very accurately. In fact, the more accurately they are set, the less adjusting will be required later. Column E provides the target milliamp numbers required. There are only a few of these measurements required. Column F provides the reading that should be obtained on the SAS indicator. Some of these indications are clearly marked on the indicator, such as 1.0 and 1.3, while others, such as 1.02 and 1.12, must be interpreted by the mechanic. Remember that to provide an accurate reading, the indicator may need to be lightly tapped during the process to minimize indicator friction error. Friction error is removed automatically in flight through normal aircraft vibration. We're adjusting the computer to achieve 2 primary purposes. Number 1, The computer must provide the proper voltage output to accurately drive the SAS indicator. Almost every adjustment made to the computer requires that we check the position of the SAS indicator needle. The second purpose in adjusting the computer is to provide the proper milliamp output to energize the SAS servo clutch. It should also be noted that some of the adjustments interact and affect other adjustments as well. The SAS indicator may also need slight tapping to ensure that the needle position is accurate. Work slowly and carefully, as an improperly set computer will make the system much more difficult and possibly even impossible to set up. Make certain that no steps are missed or performed out of sequence. When an adjustment cannot be obtained, go back and double-check the sequence as called out by the manual. Another important point to remember is to extract new numbers from the computer if adjustments were necessary during the in-flight setup. Normally, if the computer was properly ground set up and no significant changes have occurred to the aircraft, there will be no adjustments required during the flight test, and so therefore no new numbers will need to be extracted. If adjustments are made, the new numbers must be recorded. This is accomplished using a new copy of the SAS setup form. The procedure is similar to the setup, although now we adjust to known voltages and read what the variable voltages have actually been adjusted to. These will be recorded in column B for use during future setup and testing operations. The corresponding voltages for the intermediate flap settings of 3/8 and 5/8 must also be determined by plotting the full up and full down flap numbers on the SAS computer calibration graph. Depending upon the maintenance activities involved, it is usually a good idea to check the vane and flap position transmitters as well. The SAS tester allows this to be easily accomplished. The vane must be locked in place on the fuselage using the location tool. Check to see that the proper voltage is present using the tester. Adjustment of the flap transmitter is a little more involved, since it can be adjusted by two means. First, the pot may be rotated in the shaft to change its resistance and affect the voltage output. This is usually accomplished with the flaps full down. If the range of resistance change is insufficient or too great, this is usually adjusted through changing the attaching point of the push-pull rod to the potentiometer arm. The farther away from the potentiometer shaft the attaching point is moved, the less the amount of pot rotation. This adjustment is usually made after measurement of the potentiometer output with the flaps full up. Of course, any adjustments made will require that the reading at full down be checked as well. There is no adjustment for the intermediate flap settings, although if full up and full down are set correctly, the intermediate steps will be correct.